Hello, everyone. In this video, I will be demonstrating the actor-partner common fate hybrid model. Um, uh, I will specifically be talking about the actor-partner common fate actor-partner dual level mediational model. So within the actor-partner common fate hybrid models, there's a lot of ways you can kind of piece the puzzles together. And so I'm going to go over a very specific form of hybrid model that combines the actor-partner interdependence model as well as the common fate model to test indirect effects from the individual level up through the dyadic level and back down to the individual level. So before getting started, I will show you just a brief kind of conceptual diagram of the model that we'll be building. Here you can kind of see the actor-partner common fate hybrid model. And so it is called the actor-partner common fate hybrid model because you have the actor-partner variables first and then the common fate variables second. So essentially what you have here is you have your X variable, which we will be using relationship attribution. So the way each partner interprets their partner's behavior. And so that is not a dyad level construct that is unique to each individual. And so in our sample of heterosexual couples, we are going to have a male report on relationship attributions, and we're going to have a female report on relationship attributions. And we're going to use those to predict dyadic coping is going to be our first common fate variable. And so if you're new to the common fate model, the common fate model differs from the actor-partner interdependence model in the way we account for the interdependence. So in the APIM, even though it's not shown here, you're going to have a residual covariance between these two, indicating that the attributions each partner makes are likely to be correlated with the other dyad members. But in the common fate model, rather than a covariance, we are estimating the amount of shared variation in in a dyadic concept. In this case, it will be dyadic coping. And so we have a latent variable that represents a relationship level process that is then theoretically believed to cause each dyad member's individual reports on that construct. So dyadic coping at the relationship level, that what occurs between partners, what is shared between partners, theoretically causes each dyad member's score indicated through the factor loadings that are constrained to be 1. All right, so that is the actor-partner common fate hybrid model, where individual level characteristics of both dyad members are used to predict a common or a shared outcome. The other half of this model is the common fate actor-partner hybrid model. And that is where since in the name, we talk about common fate first. We're going to have that as our independent variable. In this case, it will be relationship quality. So relationship quality is again, inherently a dyadic construct where all the questions are focusing on the relationship rather than an individual. All right. And so we're going to estimate how much shared variation there are between male and female partners. And we're going to use that to predict depressive symptoms is going to be our outcome. And so again, depressive symptoms, it's an individual level process. Although there might be some contagion or some communicability of depressive symptoms where my depressive symptoms can spill over and my partner can develop those same depressive symptoms. That is theoretically possible, but that would actually be more consistent with an actor-partner model more so than a common fate model. All right, so essentially what we're going to be doing today is we're going to be smushing these two different types of hybrid models together to examine the indirect effects from relationship attributions to depressive symptoms through dyadic coping and subsequent relationship quality. All right, so we will shift over to Mplus. And so to start, these are all the variables in our data set, and then we are only going to be using 8 variables. Dyadic reports on each of the 4 variables. Our relationship attributions, depression, relationship quality, and dyadic coping. All right. And we're throwing an ID variable in there. It's always nice to have that in Mplus in case you want to do sensitivity analyses, detect outliers, and things of that nature. All right. So we will not actually be using the define command, so I can actually go ahead and just delete that. In the analysis, you actually don't really need to type anything in here. The default is actually going to be maximum likelihood. And so I just kind of specify these other options just because in a lot of the models I run, these are kind of the defaults. My default is to use robust maximum likelihood because most often our residuals are not normally distributed. So I tend to just not use maximum likelihood very much anymore because there are potential problems associated with using maximum likelihood when our residuals are not normally distributed. We have deflated standard errors, which means our test statistics are too high, which means we are going to run into a type 1 error. So I use default, which provides a scaling correction factor to the chi-square, which then readjusts our standard errors. Model equals no cove. Essentially, Mplus by default will suppress all of the covariant, or Mplus by default will estimate all of the covariances among your exogenous variables. So let's say you have just a kind of a view of multiple regression with 4 independent variables. You do not have to specify the covariance between them in Mplus. It will do it for you. So I don't want that to happen. It won't actually have much of an impact on this model, but when you get into the more advanced common fate models, and especially when you're using phantom variables, this no cove option is really, really useful. All right, and we will not be bootstrapping because you cannot bootstrap when you are using robust maximum likelihood. You have to use delta method to calculate those indirect effects, which is, again, an Mplus default. So first, we will go over the measurement model. So if you're familiar with the common fate model, this is nothing different. We create our common fate latent variables by using the by statement, which indicates a factor loading. And then we are going to create 2 latent constructs, each indicated by both dyad members' reports of the construct. So this is for dyadic coping. And so we have female version of dyadic coping, and then we have the male reports of dyadic coping. And you'll notice all of the male variables are have this underscore M at the end. All right, so that's how I distinguish them within this data set. And then we're doing the exact same thing for relationship quality, right? And then, so that's our measurement model. And so you would want to test this model first. And we actually can. So we'll go ahead and we'll just block comment out everything here. And then we'll just, actually, we want to keep that last line because those are our covariances. And so you need to covary the within person effects. So these are both female reports on the construct, and these are both male reports. So I want to correlate them with one another because there might be a common cause that varies across partner, for example. All right, so this is kind of, again, just a default specification for the common fate model. So we can go ahead and we can run this to see what our, we're actually gonna need to make one more change. We need to get rid of this and then re-estimate it because it was thinking those were in the model when they really aren't. And so it looks like we actually have something else happening. So we just have male and female. And so I'll just start from scratch. And so we have, CSI dyad by CSI at 1. and then we have CSI underscore M at 1, and then we're going to have dyad cope by dyad top at 1, and then dyad top underscore M at 1. And then we're going to want to covary our residuals. So these are, again, the female reports. So we'll just throw the width on. And then here are the male reports. So we will do the width, which again specifies a covariance or a correlation in Mplus. So this should be all that we need in the model. So actually, we're still getting a funky result. So let's suppress this. Oh, we need to specify that that regression coefficient. That's one of the things that was missing. So CSI dyad on dyad cope. All right. There we go. That's perfect. So this is our model output. So your common fate, base common fate model will only have 1 degree of freedom. Oftentimes you will see this value being significant. Again, I don't pay a whole lot of attention to the chi-square and low degrees of freedom model, but it's something to at least keep your eye on. You should know that it is significant. You should be aware that it means there might be a misspecification somewhere in the model. But again, due to sample size and in the nature of the model, I'm not surprised. And so I'm kind of, again, keeping an eye on it, but it's not something that worries me. Likewise, I'm not worried about the RMSEA because it is biased in small degree of freedom models that a Dave Kenny 2015 article has shown. So CFI and TLI are both within normal range, and then we'll scroll down to the residual matrix, and we'll take a look to see if we have any z-scores that pop out, and as you can see, none of the z-scores are significant. So our z-scores, any of these values above 1.96 indicate that they are significant. Actually, there is one. There is one that is significant here. But it doesn't seem to be, it's not flashing red lights at me. And again, this is kind of where I'm sensing there's a little bit of caution to be had here. And this is something I'll want to keep an eye on, you know, as I add more parameters to the model. Is this guy moving more extreme? Is it moving towards 3, 4, 5, and 6? Then I know that there's something, you know, that's genuinely wrong with the model. Otherwise, I'm kind of waiting to see, and if it's not really moving or if it's even going down a little bit, then I am not really all that worried about something to this effect. So I'm really looking for outlying factors or outlying values. But if my model had everything that was at 5 or above, you know, highly significant z-scores, then that would really worry me, and that means I just have a really bad model. But when a lot of them are non-significant and you kind of have one guy that's kind of poking up a little bit, but doesn't seem to be, you know, too far out of the range, I don't really necessarily, that doesn't worry me all that much. It's something that I'm going to keep in the back of my mind, and it's something that I'm going to report in my document. All right, so we've kind of gone over the specification of the common fate portion of the model. And so here I'm actually going to just do some undos, and so I can get the old syntax back where I have the full model. And it's always nice to specify your measurement model first. So if you run into errors, you're not running through all of these lines of code trying to figure out where it is. It's much more isolated, and you can kind of figure out where things are at in a much easier way. All right, so I'll uncomment that out. So that was this portion of the model. And so now what I'm going to do is I'm going to add in my dependent variables and my independent variables, because both of these are my mediators. So thinking back to the diagram, that's what these guys are. That's what we just specified, was these two latent variables and their covariance. And so here we are adding female depression, and I am regressing it on both mediators as well as both sets of independent variables. And I'm doing the exact same thing for male depression. All right, so in this example, I am hypothesizing based on my model that the effects from attributions, which are independent variable, to depression is not fully accounted for by dyadic coping and relationship quality. There's things that are outside this model that are possible mechanisms linking cognitive processes and how we interpret partners' behavior and how that relates to our own levels of depression, right? And then we have our CSI, relationship quality, which is our second mediator. I start with the dependent variable and work backwards in how I code my syntax. You might have a different framework, and that's perfectly fine. It shouldn't influence your results in any way as long as all of your syntax is correct. Likewise, I also believe that based on this model that relationship attributions for male and female partners, they might have an effect on dyadic relationship quality beyond dyadic coping, okay? And so from my theoretical underpinnings that I have in building this model, I'm saying either I have a reason to believe that, attributions are going to have a direct effect on relationship quality, or I might not be sure. The body of knowledge might not be that advanced, and so I'm going to estimate them first, and if they're non-significant, I'm just going to prune them off and see what are the ramifications for my model. And then we finally have dyadic coping, which is our first mediator being predicted by each individual partner's levels of attributions. And for the attributions measure, a higher score means more negative attributions, right? And then we have the actor-partner covariances. And so those were actually not shown in the diagram just for simplicity reasons, but we believe that depressive symptoms might be correlated, and we believe how partners interpret each other's behavior might also be correlated as well. And then we've already talked about this, but these are the common fate covariances that I actually did show in the model. That's these guys up here, those within person effects, right? So within this model, we have each dyad member's independent variable, RAM and RAM for males. It is presumed that the effects of the independent variables on the individual reports of the dyadic variables, relationship quality, and dyadic coping. I'll go back to the figure that we'll say X, all the X1s or the ones indicates male and the 2 indicates female. So all of the ones are going to be male reported. All right. All of these, again, are going to be reported by males. And so we have a reporter bias specified up here in the common fate model portion, but we are kind of assuming that this X, there's not a covariance between X1 and CF11, this one right here, or there's not a covariance between X1 and theta delta 2. We believe that the correlation between the two is going to be captured by this regression coefficient, gamma 1. It's going to be captured by this variance of the factor, and it's going to be captured by this factor loading. All right. And so if there's something left over, then that's something we might want to look to a modification indice about, or perhaps we see that the first variable, in our case, it's going to be dyadic coping, maybe in the residual matrix, we're seeing that this is being over or underestimated in its significance. So we might want to actually investigate that a little bit more, because if we need to add in either a regression coefficient or a covariance, then we absolutely need to do that, because if we don't, this regression coefficient is most likely, this is going to be the most likely suspect of where it's going to be overinflated or it's going to be underinflated, because this relationship is trying to get out, is trying to be specified, it's trying to be known. But the only way this X variable and this residual or this common fate variable it's able to kind of get out is through I guess there's two pathways, through this gamma 1 pathway. So here, then you go around the factor, and then you go down through the loading. You could also potentially get another covariance. I will briefly add in a residual covariance so you can see the second path that I'm about to trace. We'll throw a little covariance right here. Another way it could get out is you cross this covariance. So you go over to the female, and then you go up gamma 2, then you capture the variance of here, and then you go back down the factor loading. So if we're seeing that that this is being underestimated, it might be that these gamma 1 and gamma 2 are going to be overinflated, that those are going to be higher than they potentially would or potentially should be, and that's a misspecified model, right? So that's something we'll take a look in more depth in a second video, where I'm going to show you all and demonstrate my model building strategies for this model. But for now, just know that that's an assumption that we are making in this model, because again, those assumptions are really, really important. And if you don't know the assumptions of your model and of your statistical package, then that can lead to potential erroneous interpretations of coefficients that are incorrect. And so we will go back to Mplus, and again, this is very standard output for the models that I run. We have sample statistics. We have the residual, which is the variance covariance matrix that for the estimated, and the expected model. We have Tech 1, which labels our parameters in case we get an error message. We kind of know, or we're ballparking where that potential misspecification is. We have STDYX, so we're standardizing our Y and our X. We have mod indices, and we want those confidence intervals at the 90, 95, and 99 percentile. All right, so the last thing we need to do is specify the model indirect, or the indirect effects. And so we will be estimating 4 indirect effects. All right, so we have CESD for women. It's going to be IND to specify that indirect effects. And we have the RAM for women, right? The attributions that they make about their male partner's behavior. And then we also have the indirect effect from their partners' attributions, because it could be that males make more negative attributions, which impacts dyadic coping, which impacts the relationship quality, which impacts female depression, all right? And so we're just going to replicate this for men. So we'll just include the CESD_M, IND, RAM. So that's male depression indirectly related to female attributions. And then our final indirect effect will be through male's own attributions. All right. So in Mplus, you cannot estimate multiple indirect effects on the same line, kind of like you saw me do up here. You need to specify them on separate lines, and there has to be a semicolon at the end. So we can go ahead and we can run this model, or Mplus can yell at us. Let's see what I need to do. I need to remove that statement from earlier. where I commented it out, and hopefully that is I used a colon. So you can see small Mplus is incredibly finicky, and you can see that small typos can impact your model estimation. All right. So you'll notice that you have the model terminated normally, and then many of you might see this message. This message is something you probably don't have to worry about. And the reason is we can estimate the solutions for the latent variables that are in our model in several different ways. And so we're just choosing to freely estimate the means and the variances, and we're constraining those loadings to be the same from a common fate perspective, but there are actually going to be other ways to estimate the latent means and variances. So this is really why you're getting that message. So it is not something to worry about, but if you wanna just double check, you can just increase your number of start values and just throw them in here. And you can just increase this to, do 10 to 20 to 30 to 40 to see if your solutions are changing, right? If you're familiar with mixture modeling, you know that this is a core feature of mixture modeling, so you don't find those local solutions. All right, you want to find that global solution. All right. So again, that's something you can largely ignore. We'll take a look at model data fit, and we have a decent fitting model, even though this chi-square is significant. It's within range. It's not, this isn't 80, and so it's raising kind of yellow flags that I might need to look at the model, but it's not really telling me that there's any major problems because it's a highly, highly sensitive test. Likewise, the RMSEA, it's moving in the right direction. Again, we still don't have a whole lot of degrees of freedom. And so this is kind of flashing yellow lights. This is something I want to consider. Maybe there's a misspecification in the model, but it's got not a tight confidence interval, but it's not a country mile wide either. It's kind of somewhere in between. So I'm not I would be bragging about this, but I also wouldn't say that this is a poor model and I have to revise my model. CFI and TLI are, again, within range. So again, these aren't anything to brag about, especially that TLI, but it's not anything that is out of the realm of a good fitting model. All right. So we'll scroll down to our residual matrix to see kind of what's going on down there, and see if there's potentially any outliers in terms of those z-scores. All right, so I'm seeing a couple negative 2.5, 2.5, 2.4. Everything else is 1, 3.2. And so it looks like all in all, nothing too crazy. I am thinking about this one a little bit. Even though it's not far beyond the others, that's actually one of the pathways that I had mentioned. That this is actually the pathway from female relationship attributions to male dyadic coping, and that's actually overestimated according to this statistic. So we'll take a look in our model. We might make some changes and see what that actually does. Again, I'm going to do that in a more nuanced way in another video. Again, this video will be just largely based on the estimation process and model checking and interpreting the parameters. So you will not see that here, but I will be sure to upload another video that goes over it. So overall, I'm fairly happy with the fit of the model. There's some things I might want to tweak, but overall, nothing is kind of screaming at me saying there's big time problems here. There's light chirping in my ear. So Well, we first have our common fate parameter. And so we can see a 1 standard deviation unit increase in dyadic coping leads up to a 0.722 standard deviation unit increase in relationship quality. And that, again, is highly, highly significant. We find that both male and female negative attributions are not associated with relationship quality. So again, this was our second mediator, right? And so there's also an indirect effect, even though we didn't explicitly estimate it, from each person's report on the RAM to dyadic coping to relationship quality. So it appears that these effects are significant, and they're kind of picking up that association they're accounting for that association between the RAM and how happy the couple is in their relationship. And so we have I'm going to interpret this as significant. Actually, I'll just interpret this one. So we have the women's report of negative attribution. So the higher the level that women make in terms of negative attributions, or the more negative attributions women make about their male partner's behavior, a 1 standard deviation unit increase in that negativity is going to be associated with a 0.36 standard deviation decrease in how well the couple copes with stress in their relationship. Right. So what this is kind of telling us is that it's really how women interpret their partner's behavior that is dictating how well the couple comes together and copes with stress, and how they communicate with one another in terms of stress and navigating stress together as a dyad and as a couple. So that this is clearly saying that women are driving the boat. The male is 0.052, so it's not significant. My guess is if we fix this to be 0, because it's also non-significant, this is actually going to increase. It's going to get more negative, and this is actually going to become significant, would be my hypothesis. So we might actually find something there when I'm kind of getting rid of this effect here. But for now, in this model, the extent to which males make negative interpretations about their partner's behavior does not have a significant bearing on how well the couple copes together with stress in their relationship. Okay. And so we will go to we'll actually look at the direct effects from depression onto RAM. So these will be interpreted as actor and partner effects. And so first we have women's. And so the more negative attributions women make about their partner's behavior does not have a significant effect on their levels of depression, right? So it appears our mediators are doing a pretty good job at picking up on the association between CESD and negative attributions. All right, so, and that's an actor effect, right? So we also have a partner effect. So the more negative interpretations that males make about the female's behavior does not directly influence females' level of depression after accounting for relationship level dyadic coping and relationship level couple satisfaction. All right, so there's no direct effects for women. On the other hand, we find some interesting things down here for men, is that the more men interpret their partner's behavior as negative indicates that they are more depressed. Specifically, a 1 standard deviation unit increase in negative attributions leads to a 0.281 standard deviation increase in levels of depression among men. So that is an actor effect within person. And we see that the partner effect from women is not significant. All right. And so essentially, those are the basic parameters and how to interpret them from a direct effect perspective. So now we will scroll down and we will look at the indirect effects. We might glance over the R squared and see how our model's doing. Again, our model's actually doing a phenomenal job at capturing dyad level relationship satisfaction. And so here you will have the direct and indirect effects. I tend to skip over this because we requested confidence intervals. And so to me, this gives me, this is a better display of information. It's identical information to what you will get above, but I like looking at the spread of the variability within those 95% confidence intervals, which you can kind of glean from looking at the standard error above. You can look at the standard error here and just get a sense. You get a total standard error, and you also get one for each indirect effect. And so you in your head, you can multiply the standard error by plus and minus 2, and that's going to give you your 95% confidence interval, your upper and lower limit. But I'd rather not do that math, and I'd rather see it visually. And that way, it's just less information I have to hold in my head, and it's information I can actually see on the page. And so looking at the indirect effects, we have a non-significant indirect effect for specific indirect effect 1 and specific indirect effect 2, because you will see that 0 is in between the upper and lower bound. So if 0 is between negative 0.039 and 0.031, you will find that it is non-significant. All right, so these first two indirect effects were non-significant, but we also have this serial indirect effect. Again, essentially the serial indirect effect is the direct effect from your independent variable to your first mediator, from your first mediator to your second mediator, and from your second mediator to your dependent variable. And you're essentially taking the product of those three pathways and examining whether or not that's significantly different from 0. And as you can see, 0 is not within the 95 or even the 99% confidence interval. So we can say with a lot of confidence that our indirect effect from female reports of negative attributions to female reports of depressive symptoms is significantly different from 0, given that the null hypothesis is true. All right, so we'll scroll down, and again, this is an actor-oriented indirect effect. So both of these are actor effects, where it was female attributions and female depression. So we'll scroll down, and we will look at the effects of negative attributions reported by males to female depression. And as you can see, none of the indirect effects are significant. All right, so it does not appear that male negative attributions has an indirect effect on female depressive symptoms via dyadic coping and relationship quality, because again, all of these 95 and 99% confidence intervals contain 0, although this one is kind of hovering near significance, but it is not significant. That would be significant around 0.07, 0.08, 0.09, somewhere in there, and you can actually look above to get that exact p-value in the first set of indirect effects that I glossed over. All right, the other indirect effect from female negative attributions to male depression. Again, we have both of these specific indirect effects 1 and 2 are non-significant, but we have a significant serial indirect effect, and it is significant at with a 99% confidence interval, because again, 0 is not in the interval between 0.011 and 0.109. And finally, the last indirect effect, this is the actor effect within males. None of them are significant. So as you can see, there's negative values over here and there's positive values over here, which again tells us that that male negative attributions does not have an indirect effect on male depressive symptoms through dyadic coping and relationship quality. But again, as you notice, that female negative attributions negatively impacts her own levels of depression and her partner's level of depression. Because again, if we scroll back to those direct effects, it's female negative attributions that have a substantially stronger impact on how the couple copes together with stressful situations. So the negative attributions of the female are driving dyad level processes that ultimately impact both partners' level of depression. All right. So hopefully this was a helpful introduction to understanding the cross-level mediation model, specifically the actor-partner common fate actor-partner indirect effects model. Wickham and Macia in 2019, I believe, in Behavioral Research Methods, I think that's the journal, did a paper on this, and I will post that in the description for further reference, as they provide a lot of details and also some Mplus syntax. So hopefully this was helpful in helping you, again, kind of combine two different dyadic methods that together can kind of overcome the limitations of each method on their own.